So to practice some problems using Euler's method, we have two steps of equal size. So the delta x is equal to the b minus a over n, with 2 being the n. So 1/2 minus 0 over 2 is equal to 1/4. Using a table of values to organize, we have x comma y as our points, dy dx, multiplied by the delta x, which represents the delta y, and then delta y plus the y sub 1. Our point that we're given for x and y is 0, -1. That was the initial condition. Dy dx, which is the y squared, multiplied by the quantity of 2 times the x value plus 1. So dy dx is equal to 2. Multiply dy dx by the delta x, so 2 times a fourth, which is 1/2. Take that 1/2, add it to the y value of -1, so we have -1/2. So now the point is 1/4, and the y value of -1/2. Calculating dy dx, taking that -1/2 squared, multiplying by the 2 times the 1/4 plus the 2, so dy dx is equal to 5/8. dy dx of 5/8 multiplied by the delta x of 1/4 is 5 over 32. Delta y, which is 5 over 32, add on that y value of -1/2. Getting common denominators, we have 5 over 32 minus 16 over 32, which is -11 over 32. So we have the point 1/2 comma -11 over 32. So to approximate the f of 1/2, we get -11 over 32. Again, we're going to use two steps of equal size. Our delta x is going to be b minus a, so 1.4 minus the 1 divided by the 2 steps, which is 0.2. Again, organizing our information into a table of values, we have x and y as our point, dy dx multiplied by the delta x, which is the delta y, and then the delta y plus the y value. Original point given was 1, 15. The dy dx from the table is equal to 8 at the value of 1. Take that 8 multiplied by the delta x of 0.2 to get 1.6. Take the 1.6 and add it to the y value, so we get 16.6. So now we have the point 1.2 and 16.6 is the y value. The 1.2 slope is 12 from the table. Take 12 multiplied by 0.2. We get 2.4. 2.4 plus that y value of 16.6. That's 19. So 1.4, the y value will be 19. So f of 1.4 using Euler's method is 19. Again, using two steps of equal size. So our delta x is the b minus a over 2. So -1/2 is delta x. This time calculating it a different way, we have f of 1 is equal to 0. That's our original point. So f of 1/2 is that y value plus the dy dx multiplied by the delta x, and dy dx at our point 1, 0. So that y value of 0 plus our slope at 1, 0, which is 1, and multiplied by the delta x of -1/2. So f of 1/2 is -1/2. Then f of 0 is -1/2, the y value from f of 1/2, plus the slope, the dy dx, at the point 1/2, -1/2, and multiplied by the delta x. So the y value of -1/2 plus the slope of 1/2, -1/2, which is 3/2, and then the delta x, which is -1/2. So f of 0 is equal to -5/4. So using Euler's method, the approximation for 0 is -5/4. Again, using two steps of equal size, delta x is equal to b minus a over the n being the two steps, so 0 minus -1 over 2, which is 1/2. The original condition was f of -1 is equal to 2. Adding on a half, we'll have f of -1/2, taking that y value of 2 plus the slope calculated at that point, -1, 2, and multiplied by the delta x. So the y value of 2 plus the slope at -1, 2, and then multiplied by the delta x of 1/2. So f of negative 1/2 is equal to 4. Then f of 0, using that y value of 4, plus the dy dx, the slope at that point, negative 1/2 comma 4, and multiplied by the delta x. The y value of 4 plus the slope at negative 1/2 comma 4, and then multiplied by the delta x of 1/2. We have 4 plus 1/4, so f of 0, the Euler's method approximation for f of 0, is 17/4.